All right, so in today's notes, we're going to try to answer the question, how do we find compositions of functions? Well, function composition is when the output of one function becomes the input of another function. So here I have it kind of laid out with Venn diagrams, or a type of Venn diagram. So if we have the input of f is typically this x, right? And the output of that f would be this f of x. But here you see that f of x is also the input of g, to where the output of g will be this g of f of x. Okay? So let's see how that works. Up here I have three functions that I'm going to use throughout the rest of the video. And then here will be our examples. So we're going to find f of g of x. Well, here we see g of x is 3x plus 3. So I'm going to replace g of x with 3x plus 3. So now, this 3x plus 3 becomes the input of my f, right? So anywhere that there's an x in f, I'm going to replace it with 3x plus 3. So here I have, that's my f function, and I'm going to replace the x with 3x plus 3. Now I'm going to have to multiply this out. This would be 9x squared plus 18x plus 9 minus 1. And so, combine like terms here at the end, we have 9x squared plus 18x plus 8. If you're at all wondering how I got this from 3x plus 3 squared, you just might want to go back and review your FOILing rules. Okay, so this is f of g of x. And because it's a quadratic, we don't have an x in our denominator, it's not in a square root, we say that our domain is all real numbers. Here we're going to do it again. We're going to find g of g. This is just a different way to write it, but this is basically saying what's g of x. So that's g of 3x plus 3. So I'm going to write out the function g, 3 times x plus 3, and I replace that x with 3x plus 3. So now just distribute this. We have 9x plus 9 plus 3, which is 9x plus 12. All right, so 9x plus 12, that's just a linear function. Linear functions have a domain of all real numbers. Yet again, here's just a different representation. It looks like hog, but it's h of g of x. Been using a lot of g of x here today. I don't know why. H of 3x plus 3. All right, so now I'm going to write out my function h, 2, and then replace the x with some parentheses to the negative 1, so 3x plus 3. Now, anything to the negative 1, that just means that it just needs to be sent to the denominator. So we have 2 over 3x plus 3. I check, is there anything I could factor? Yeah, I could factor the denominator down to 2 over, I could factor out a 3. But still nothing cancels within the numerator and denominator. So this is as far as this can go. But now I have an x in the denominator, so I'm going to have to set the denominator equal to 0. So 3 times x plus 1, set this not equal to 0. Divide both sides by 3, and the 3 goes away. So x cannot be equal to negative 1. So my domain is all real numbers except negative 1. Again, and that's just because if I plugged in a negative 1 into this denominator, it would cause it to divide by 0, and we can't have that. All right, so for the last example, I lied, and we're actually going to switch up f of x and g of x. So we have x minus 1 and square root of 2x plus 3. So we're going to find g of f of x. I'm going to go ahead and say you try to figure out the composition, and then we'll come back together for domain and range. So go ahead and pause the video. All right, so hopefully you got down to g of f of x is equal to the square root of 2x plus 1. Now we have to remember how square root functions work in order to find the domain. Remember that square root functions, they kind of look like this, right? You cannot take the square root of a negative. Okay, so here, let me just kind of get rid of that. If you can't take the square root of a negative, then this 2x plus 1 needs to be greater than or equal to 0. So now we just solve for x. 2x needs to be greater than or equal to negative 1. X needs to be greater than or equal to negative 1/2. So this has a domain of x is greater than or equal to negative 1/2. All right, and that's composition of functions.